Okay, so this is a video on how to do a chi-square independence test using raw data, and I am gonna pull back up that data on good stuff. Where'd it go? Where'd it go? Where'd it go? Me and my gazillion, the COVID threat data that you guys have. Okay, so this is the COVID threat data, which I like because it has a whole bunch of categorical stuff. And so what we want to do is we want to do a chi-square test of independence. So there's a lot we could do in this one, by the way. There's tons. So we could look at the association of gender versus age, which really has nothing to do with COVID, but we could look at that. We could look at region versus gender. Let's do that. Let's look at region versus gender. In other words, what we're looking at when we do that is we're looking at whether the distribution of males and females is different in the different regions. So to do that, these are the two columns I'm interested in looking at the association of. The first thing we're going to do is we're going to do a frequency table. And it's not as simple as having one variable. It's under descriptive stats, and it's called crosstabs. This in Excel, these are pivot tables. And if you took my Excel, you learned how to make pivot tables. Hopefully another professor taught you that too. But so one is rows and one is columns. It really doesn't matter which is which because it's a table. You can do gender in the rows, gender in the columns, doesn't matter. So I'm just picking the two variables, doing a table, and it's going to give me this nice little summary table. And right here, the region, so there's 101 males in the Northeast, 108 females. These actually look pretty evenly distributed. So I'm not really expecting a significant difference in my chi-square, but there could be. I don't know. There's a pretty big data set, so there could be. So this is what's called a crosstab table, where it's giving the two different variables and then the counts. Each cell is males in this region and so forth, and then females in this region. And so that's what chi-square calls a contingency table. It's called a crosstab in SPSS, and it's basically a pivot table in Excel. So that's just a table of the summarized frequencies by divvied up by one variable. I mean, you can do also the individual frequencies, but when you do this, you can't tell, like if you just do these, you can't tell how many males are in what region and so forth. This is the individual, males and females. They're not done by this. You can do the percents in here too. In the next video, I show you how to do that. But so this is just the crosstab table. There's no chi-square test yet. So what the chi-square test is going to do is it's going to test whether or not the distribution of males and females is different in the different regions. So in other words, is there like some kind of, are we 50-50 in all the different regions, or is it like 50-50 in the Northeast and then like 20-80 in the South? So the chi-square independence test, that's what it's doing. It's looking at the overall distribution across the cells in terms of whether or not for certain variables the percentages are different, and there's like some type of maybe in the West, they're doing like 80% females, and in the Northeast, it's like 80% males. So that's what this test is doing. And so this test is actually very, very easy to run in SPSS, because all you have to do is analyze, or rather, you analyze descriptive stats and contingency tables. Crosstabs, sorry. And then once you have your table set up, all you have to do is go under stats and just click chi-square. That's it. That's all you got to do. It's a piece of cake. And then when you do that, you get the chi-square, and you want to go by the Pearson chi-square. There's other variables. There's other measures in here we really don't care about. They're basically this. The first one's the same anyways. And then look at the p-value. So the p-value here is 0.943, which basically means that there's really no. It basically means the distribution of males and females is pretty much equal across all the different regions. So there's nothing funny going on there. Okay. Let's do another one of these for fun. Let's look at let's look at what would be fun to look at? Let's look at education level, or whether or not they think COVID is made up. That looks like it might be fun to look at. So let's look at that. Let's go under Analyze and Descriptive Stats crosstabs, and let's do COVID made up. We don't want to, by the way, you don't want to keep more than one variable in here, because you're going to make like a mess. It's going to be like uninterpretable. So let's do COVID threat and then education level and see what happens here. And then let's check off the chi-square to run the test, and let's hit go. I have no idea what's going to happen because I haven't run this before. And here we go. So these are different education levels. They're kind of ordered in terms of degree level. And then it's looking at whether or not people's opinions of COVID threat differ by education level. And surprisingly, they don't. So the p-value here is 0.154. So that, I mean, I was kind of expecting that like people without as much education might not understand the threat and people with more education might, but there's no significant difference here. So you're looking for a p-value less than 0.05 here for there to be some type of linkage in the distribution. And I don't know if I can find one that has that. Maybe metro area versus education level. So now you got me like hunting for significance, but I don't see the significance. Let's just run this one quickly. But I think for your homework, there's a bunch of them for your homework, so maybe we'll see some in there. So let's do COVID threat again, or COVID made up. Let's do COVID made up versus COVID threat. I forgot what I said I was going to do, but this is what I'm going to do. And then maybe oh, this one is significant. Okay, cool. So this one, whether or not COVID's made up and COVID threat, this one does come out to have a p-value less than 0.05. And what that means is that the people who said that COVID was made up a lot tended to think it was like not a threat more than the people that said that it was or some threat. So there's a relation between how people respond on COVID being made up versus COVID being a threat. And there's a significant linkage in how people respond. And you see that in the independence test being significant. And that's what that means. Okay. So these are pretty easy to run. As long as you run the crosstab, just check off the chi-square and you get the chi-square significance value. Okay. So that is our chi-square test of independence given raw data.